Hi folks, welcome back to the Combo Classroom. Let me double check that we are going properly. I'm going to make my face big for a moment while I set this up, and to any viewers watching this in the future, we'll have various fun topics today, so keep an eye out for the timestamps. I'll be putting chapters when possible. On these longer stream type videos where we cover a bunch of random topics and have fun that way. Now, I forgot to bring my phone out here to check the chat, so I may need to grab that. Oh no, here it is. That will help me check our chat. And today, among our various topics, we are going to have some sneak previews of the next video coming out with all of these wild types of numbers. A little bit of fun behind the scenes stuff I want to share. Of course, some nature appreciation because I can hear some birds, and I can see the stray cat I adopted, Sassafras, over there. And he's probably pretty camera shy, might not pull a dandelion on us, but I'm sure that we'll get our time for you to see how much of a loving creature he is too. No. Sorry for the ads there. Now, while I log on to my stream comments here, let me note that the last stream I did, my internet did something weird and crashed, and then YouTube processed it weird, so I had to re-put it out. And so the last stream may be in backwards halves, and we didn't fully finish deducing which of the first 100 numbers were the least interesting by some silly standards. And so we will return to the least number awards at some point in the future, although that will not be today. And I haven't fully put timestamps into those videos yet. In fact, if any of my viewers want to help me out, it would be helpful sometimes to leave a comment after the streams. If you skim back through the stream when it posts and see when certain things happened and leave a timestamp, that would be awesome because I don't always have time myself. I'm busy with filming and writing and stuff and studying, and that might speed up my ability to do that if one of you helps me out. So after this stream processes, for example, or for my last two streams, which I didn't fully have time to do that for, if anyone wants to leave a comment with some chapter timestamps, I'll pin whichever comment seems to suit it best and be most detailed about that. Someone's mentioning that there is a strip file of the OEIS that for the initial terms, you can download it in 80 millibytes or something. I forget the term for that. Is that it? Megabytes. I'm so not a computer tech that at first I'm like, milli something? That's a little m. But yeah, I should download that at some point. That sounds really useful. I'm not a computer guy, meaning I'll probably like it even more to have a downloaded copy of that I may even print some of my favorite terms. There's actually a book copy of the OEIS that I believe may have been started before the resource website itself, so I may just get a copy of the book at some point as well. And someone asked, how am I? I'm pretty good. It's quite cold out here, and there was some wild fog this morning. I'm in the Bay Area of California, where some mornings it's insanely foggy, and so that was interesting. Someday on our stream we'll catch that, especially if we do a field trip down by the marina. We'll get some extra fog on some days. So it's nice and chilly out here, but I have my clocks and numbers and birds and my viewers, and that's pretty great. So, you know, my life is, as usual, pretty tricky. I have a lot going on mentally and physically to deal with, but I make it work, and somehow we are now past 90,000 combo lords on here, which is pretty magnificent. So we'll try and keep up that cool growth and see if we can get to 100,000 in grade -1. Would be insane. And even if we get there in early grade -2 instead, that will still be absolutely awesome. So someone says they're wondering about the, quote, persona I have with the hat and lab coat and stuff. It's not really fully a persona. It is the Domotro side of me, which is a big side of me. And I wear the hat mostly these days because my hair is super crazy without it. My hair is just a wild mess now. And I decided I might not cut it until grade -2 starts. So this keeps it more tame, and it's kind of chilly out here. And the lab coat protects me from the elements. So I like my lab coat. It helps me out. So someone's wondering, where did it come from? And I'm not sure what you mean, where did what come from? So, some of our topics today that we're going to cover include a little meditational activity we might do during some of the chatting, which is today's one of its holidays that it happens to be. And let me pull up a list of all of the, according to one of the sites, days that have been noted as today's international or whatever day of so and so. As we noted in an earlier stream, each day is many holidays. And so one of the activities we'll be doing in the background relates to one of these holidays. And let me shrink my face to show you. So International Daisy Day is pretty cool. I'm not sure if I have any of those in my garden to observe though, but we can try and appreciate flowers. Data Privacy Day is a kind of funny one, but does make sense. Various things. Probably have a kazoo somewhere. All of these seem pretty interesting. We're not going to round up a rattlesnake, but the meditative activity we might do is International Lego Day. I do have an old Lego set we've seen out here a few times that's been rained on, but since Legos are in plastic and are plastic themselves, I think it's only the box that's ruined. And so I figure, let me find that Lego set in a minute, and at some point during the stream, when I'm just ranting or chatting about something, we'll build the Lego at the same time. Although they are something that can be considered like a kid's toy, I think we can get some interesting mathematical and scientific engagement out of them, similar to how bubbles can be considered a kid's passion, but we can get a lot of interesting things out of that. So, to find my Lego set right here, we're gonna have to look inside a pretty crazy box. Now, I actually see it right away in the box, but we might as well look and see what else is in this wild box. I have two boxes like this that are, when it was raining, the place that I could keep stuff safe enough in the combo classroom. One of these plastic boxes. I also sometimes try and put a tarp over stuff when it rains, but that doesn't fully work. We may need to figure out some sort of canopy situation for grade -2. And in this box of things I've protected, we have a variety of interesting items that could come in handy. You know, we have rubber bands. We have a whiteboard marker, which it's good to know there's a backup in here. We have a thing from a game that happens to say combo. We have water guns and some random things like some silly string that probably doesn't work anymore. And some functional things like a can opener. We also have a balloon here or two that I might as well blow up for the stream. And of course, we have what we were looking for, which is this Lego set. The box is destroyed from the rain, but the set's probably not. And so I'll keep this out here on my stack of books. Whoa, hey Sassafras. In case we want to try to build it in the background of any of our chatting. Someone's wondering about what are the numbers on the whiteboard on the background. Good question. And that will lead us into an activity that's related to some sneak previews of what's coming in Combo Class Land. Now, often I base what my main focus of my studying and ranting for a given week on is what I'm working on for my main channel episodes, because the main Combo Class channel is really my full passion project and where I get my finished ideas out, and this is sort of like my personal playground here. And one of the concepts that we've done a few shorts about is something called Pandigital numbers. numbers that have at least one of every digit that a base contains. There are also ways we could restrict it and look at the numbers that contain exactly one of each number that the base contains. And we could restrict it by saying we're not counting 0. But in general, the term pandigital would be a more blanket term that we're using to apply to any number that contains each of the digits, including 0, in a given base at least once. And these are a really rich concept, because not only are there certain pandigital numbers that we can come up with an interesting fact about, but pandigital numbers, how they exist on a number line and what they mean in any base, turns out to be a whole rabbit hole I need to lead you down. And so there's going to be a nice, awesome, very interesting episode about pandigital numbers coming next on the main channel. And like I've said, these main channel episodes for the rest of grade -1 are going to be more like 10 days apart from each other, as opposed to like 6 days apart when I was on a really fast run, because these are topics I need to be extra thoughtful about and spend a few days filming each episode, and topics I've saved all grade but want to get in the grade somewhere. And I needed to make the Pandigital episode before I can make an episode about which infinite series converge and which ones diverge, which ones go to infinity and which ones just approach a number. That's an episode that I also have been dying to make in grade -1, and I'm finally ready. But it contains a bit that needs to be already set up with our Pandigital episode. They go hand in hand, it turns out. One part of them. And so the Pandigital episode will probably be coming in a little under a week, or maybe half a week from now. Of course, we'll have a variety of streams and shorts and stuff in the meantime. And I just made a bonus video about a bunch of thoughts about why 1 isn't a prime and what it means to be a prime. And so check out that bonus video at some point. I have it in the links in this description along with our other cool links. So that's something to watch after the stream if you haven't seen it yet. And with this episode, I decided for my Pandigital numbers, let me make myself large again. With our Pandigital numbers, we need to see a bunch of examples of them, because part of the idea is that when you go up to certain points of the number line, there are a lot of Pandigital numbers lurking and hiding as lots of possibilities. And these are just some of the Pandigital numbers, some of which are very important and will show up in the episode, others of which are just random Pandigital numbers that I wrote for the background. So there's a lot in the episode, and I'll even show you folks a little sneak preview. Now, most of the sneak previews I put out go on my Patreon, and there will be on the Patreon a bunch of even deeper behind the scenes and sneak previews coming soon. But I will show you guys a sneak preview or two here, because it leads into a little funny story about the combo class. So, re-shrinking myself, I'm going to really shrink myself so you can see something. We're going to watch a couple clips. To set up today's clip, though, we're going to tell a little funny story about the combo classroom, which is that one of the main people I've been filming with is my friend Carlo. He has a very brief cameo in one of the main channel episodes. You can see him. But mostly he will be appearing in the future, because he's down to make more cameos in the science-y or snack breaky episodes. And he made a little cameo on my last Patreon video. But I've been filming a bunch with him, and I let him know he's allowed to pull mild pranks on me in the set. And we even shook hands and made a deal that either of us are allowed to pull mild pranks on each other on set. And we're allowed to do something while we're filming that will cause a little chaos, even if it causes a little chaos to the other person, because it might make some good, funny learning for the videos. And of course, we're like, don't destroy each other's possessions or anything. Mild pranks. So we made a deal on that. And I haven't pranked him yet, but I'll get him good at some point. But the way he has figured out how to prank me so far, that's made sense, is that often I have him use the hose back here to put out a fire that I've created. Often we'll set up a shot where it's like, okay, I'm going to light this thing on fire. We'll do the shot while it's burning, and then you put it out with the hose at the end. And so a couple times he has, after he put it out with the hose, put out the fire with the hose, just sprayed me in the face with the hose. And it makes funny content, so I'm fine with it. And I was like, yeah, you can do that. I totally allow it. If you think it's a good time in the video and it makes sense and you're already using the hose and you think I'm not expecting it, you can spray me in the face with the hose. It falls under our you're allowed to mildly prank me rule. And so here was the first time that happened, is a behind the scenes from the end of an episode about prime signatures. Now, this is an episode that we made a couple episodes ago on the main channel. A really great episode in my opinion, so I would recommend watching it. And here's the extended version of the clip right here. The first time Carla decided to spray me in the face with the hose that I really wasn't expecting.
Action.
All right, as we can see, even if you don't know which primes multiply into a number, knowing the multiplicity of them in this thing called the prime signature tells you a lot. And so, all right, I guess it's time to clean up all my, gather all my whiteboards.
Here you go, these whiteboards.
Oh, no, not the whiteboards. No. Thanks for coming to combo class.
So the first time he was like, was that okay? And I was like, yeah, you're good. And then this time, for some reason, he had to put out a few fires in between where he didn't do that. So this time I wasn't expecting it again. And this is a sneak preview of the upcoming episode. This is an uncut version without the music and with an extra, uncut beginning and end of the opening scene of our Pandigital episode. And it won't give many spoilers, so, it's just sort of our crazy intro. And there will be a disclaimer on this episode description, as usual, letting you guys know the thing that's in all of my descriptions, which is any use of fire or tools or other science experiments should not be copied, is not a recommendation, and is me showing you something so you don't have to try it, and is just to attract people's attention to the math. So don't play with fire just because you see this.
Action.
Hey folks, welcome back to Combo Class. I'm your teacher Domotro, and today I gotta tell you some crazy things about what are known as pandigital numbers. Numbers that have all the digits in some base at least once. And before we look at why pandigital numbers are actually a fundamental, very important concept on the number line of any base you could count in, let's just first look at a few interesting examples of some pandigital numbers that happen to have some cool properties.
I had to do it to him. I'm sorry. I had to do it to him.
I like information. I'm ready for a little fire.
So, yeah, I got myself into a little mess by deciding to allow my camera people to prank me on the set, but I think it'll make funnier learning experiences for you guys. So stay tuned for the actual bulk of that episode, which contains first some very interesting pandigital numbers, a few of which I've covered in shorts, a few of which I haven't covered yet, and some traits that pandigital numbers could have. And then we'll extend out to other bases and see in general what does it mean to be a pandigital number. And for a little warm up, I have 2 questions for you guys for anybody who wants to think through this Pandigital idea in advance on their own. So, to anybody who wants to try and do some deep thinking before this Pandigital number happens, before the episode about him happens, and I'm just holding it like this so we can see all these weird Pandigital numbers. Here's the 2 questions. What do Pandigital numbers mean, and what traits do they have in binary? And how would be different ways of calculating or describing how many or what percent of numbers are Pandigital? And of course, what percent of numbers is a vague question, but with other details or quantifiers, how could you calculate ways or describe ways of what percent of numbers are Pandigital? And those questions will lead you down some interesting rabbit holes that I will, guide you down when the Pandigital episode drops. And that is why we have all of those crazy whiteboards still here, because I've only filmed half of it. Some of these later grade -1 episodes that are deeper concepts, I'm going to take a few filming sessions to put together. A few takes, I got like 15, 20 takes to make sure I got it the way I wanted to express it and stuff. So we've gotten 5 minutes of the episode so far filmed of ended content, edited down, which took a couple hours. And we're going to make sure we get some episodes like this extra right and extra cool. And there's a lot more surprises coming in grade -2. Of course, we'll have a new desk and a new lab coat, and certain modular cycles will click back and repeat. But we also will have new surprises. There will be more animations. There will be some guest features. There will be hopefully a slight step up in production quality of better audio, and sometimes 2 camera people, or sometimes even just 1 camera person who's not me when I'm streaming or filming bonus videos and stuff, because a lot of them I have to like set up on a tripod myself. So I've built the grade -1 from this dirt myself, and as we are getting more help and a tiny bit of budget, although I still spend more on the show than I make, we are able to start putting together cooler and cooler things. So that's our little story about our sneak preview of our Pandigital episode. And some other things that we have planned for today are to look at a few interesting types of number, and also to maybe start building this International Lego Day Lego. So if you look up International Lego Day, there are actually a lot of sites that are talking about it. So it's pretty standardized. It's held on January 28th. That's today. In fact, my brother is actually quite into Legos still. And at some point, I'll show you some of his wild Legos. They make Legos of all kinds of wild stuff now. So, as well, as usual, feel free to ask any questions or thoughts in the chat. Since this is a more casual stream with a variety of topics, I will be a little more responsive to the chat today. And let's see what makes up a Lego and how it might relate to some interesting ideas. Well, back when I was a kid, Legos didn't come in as many crazy types of variety. There was some wild pieces, flames and jewels and plants and stuff, but the majority of your pieces were just the rectangular bricks of different dimensions and different colors. And it relates to geometry a lot. Although they're not perfect cubes, the way you stack them could represent square numbers or cube numbers. Some of the pieces fit together only with certain geometries by mirroring like things that are like platonic solids or relatives of those. Some of them also are just fun to click together, so why not? We're going to look at what's inside this beaten up one, and it seems to be the type where you're two cool traits about this Lego. One is they say it's a 2-in-1, meaning that you can rebuild it into a different type of car. They also say that pull back, meaning it's one of the type where it has some type of motor or gear in it where if you stretch it back a bit, it winds something up and it'll zoom forward. Now, this is fun if you build a little ramp or something like that and see where you can launch your little car. Now, don't worry to any fans who are just here for the math or just here for the life stories or whatever. There will be plenty of that in this stream as well. I just think this may be, a fun background activity at certain moments. However, it has a lot of pieces. It has 247 pieces. We also have these wheels separate. So these wheels probably got rained on a bunch. Good thing they're like this rubbery plastic. And it's too bad it's a car, actually. The wind-up ones are cool that it's a car, because you can wind them up, but I'm not a car guy. You get some flame decals. Alright, and you got a thick old manual. Dang, it's probably because it's a 2-in-1. It's kind of like 2 manuals. And you get your inventory. So, this is something that we'll just once in a while get out and do, a little progress on throughout the stream, possibly. But we're going to start with a little more mathematical and such discussions, because I already took a little time to discuss our Legos and unbox that. So, what we're going to do is, in my recent bonus video I made, which, don't worry, you can catch this after the stream, but it is linked in the description here, about why 1 shouldn't be considered a prime. I discussed briefly some of these cool number theory books I've been reading. And I want to give you folks an example of what it's like to jump into a book of number theory and what type of facts or weird presentations you might encounter. Because all of these are full of facts, but most of them try and have a somewhat playful approach to it. And it's interesting to see how the author mixes their own personal subjective love for certain numbers or number traits with certain facts that they feel like are important to share in that field. Now, the first book we're going to look at is our sillier book. Our sillier book is the number dictionary that's not my better, realer number dictionary. It's the number dictionary. Full of numbers. Like, really? I just ordered this on Amazon without realizing this is what it contained. So, the good news is, every page has them in the same arrangement. They all have 8 columns. They start it a little off, where 1 is a little early for some reason. However, we still could say this is a mod 8 cycle. It's just ordered starting from the numbers that are congruent to 2 in mod 8. The first column is always numbers that are 2 more than a multiple of 8. And that'll be true for every page here. Because if we're in a mod 8 cycle, the first column's always going to be 2 more than a multiple of 8. That's going to be 3 more, 4 more, and so on. Our multiples of 8, for example, will always be the second last column. We can also use this to try and investigate where squares would be or where primes would be or traits like that. Turns out that the squares have to land on these spots called quadratic residues. If we imagine squaring a number less than 8 or up to 8 and finding its remainder, that'll secretly tell us about all the other ones, because modular arithmetic has beautiful cycles. And if we imagine And we'll write this out so it makes a little sense. If we imagine in our mod 8 cycle, and you know what? We're going to go down a miniature rabbit hole. We're going to draw a mod 8 multiplication chart. Now, how are we going to do that? We're going to need to make a little chart of the values between 0 and 7 on each axis. And then we're going to need to try multiplying them in this mod 8 realm, where every number is converted to the remainder it would have after division by 8. Sounds random, but this will actually tell us about certain positions of types of number in this weird number dictionary. This is something I may make a full episode about someday, as with some topics on my stream. But if that ever happens, know that the full episode will have extra cool facts and visual presentations. And sometimes I like to use my streams to brainstorm the topics to sort of see how cool we can find certain traits about them. And go through the thought process where you can watch me investigate some numbers and see what that's sort of like. Because although I already know where the square numbers are going to land, making this table has given me a new question in my head that I'm now curious about, that we're going to see in a moment. So, here is our mod 8 table without the values filled in yet. And if we're wondering what happens when a multiple of 8 multiplies with a number, well, it'll always become another multiple of 8, right? Well, multiples of 8 are the zeros here. And so the fact that I'm going to put zeros in all of these rows can be seen as the fact that a multiple of 8 turns any other thing, if we multiply it, into a multiple of 8. We can also see it as if we multiply 0 by any of these, we get a 0 and don't have to worry about the remainder part. Now, if we multiply 1 by them, we get themselves. We'll notice a symmetry in this table because the axes are the same. So we'll have a symmetry down the diagonal axis. If we multiply 2 by things, it starts out as the multiples of 2 going up. However, when I get to 4 times 2, I'm back to 0 because it's in mod 8 land. For anybody who wants a bigger refresher of how modular arithmetic works, after the stream, watch on my main channel the episodes about clocks and with modular in the title or clock and stuff. So here, if we multiply 3 by something, 3 times 3 gives us 1 in this mod. It's 1 more than a multiple of 8. 4 times 3, 12, is 4 more. Then we're going to get 7 more. And then we're going to get 2 more. And then 5 more. That one hit all the values in a harder to remember way. And it's true that the mod 8 table is going to be a little sloppier than the mod 6 table I'm in love with that I've made a bunch of previous times. However, I would say the mod 8 table may be arguably neater than the mod 10 table that would describe our base's last digits of numbers and other traits about numbers. So now going up 4 alternates between 0 and 4, similar to how if you multiply 4 by another number, depending on what the 4 was, it may or may not turn the other into, or depending if the other one was even or not, mixed with the 4, it may or may not turn it into a multiple of 8. If 4 multiplies by an odd number, it's not a multiple of 8. If 4 multiplies by an even number, it is a multiple of 8. Alright, now 5 is going to have another more unpredictable pattern. 5 times 5 is 25, is 1 more, and then we're going to get 6 more, and then 35 is 3 more. 6 times 6 is 36, is 4 more than a multiple of 8. 6 times 7 is 42, and that is 2 more than a multiple of 8. And 7 times 7, which is 49, is 1 more than a multiple of 8. And we'll notice that the largest number has a descending staircase, similar to how this number had an ascending staircase, the lowest number, apart from 0. And that's going to be a common pattern on these modular tables, which is that 0 eats stuff, we get a symmetry, and that 1 ascends, and the highest number, apart from the 0, descends. And, although, wait, it didn't seem to fully do that. Here, let me see. 7. Did I mess one of these up? 14 is... Yeah, I messed this up. One of these that I wrote. I just wrote... Maybe I just accidentally corrected it. For some reason it said 8, but maybe it got smudged that way. It descends. So, the mod tables are cool because it's sort of like condensing a times table into a certain type of pattern. We're going to learn a bunch of patterns about an infinite times table, and this type of condensing it tells us about its patterns related to 8s. Now, the diagonal is really important because the diagonal on a times table are the spots where a number hit itself, you know, where we had like 3 times 3 or 5 times 5. And so those are the square numbers. So here in mod 8 land, all the square numbers are 0s, 1s, or 4s. And even if I continued this infinitely, this table would repeat. We'd get other copies if I pretended larger numbers should work. So this is the whole condensation, or, you know, condensed version of it. So we can see that 0, 1, and 4 are the square numbers in mod 8. These are also known as the quadratic residues mod 8. And these quadratic residues tell us that any square number, and remember by square, I'm not going to every single time say, I'm referring to a perfect square following these rules of arithmetic. We can assume by square number that a mathematician will be, you know, using pretty much a nickname, just a very common accepted nickname for a perfect square, which is an integer that another integer was able to square to. Because, you know, some nitpickers are going to be like, but 5 has a square root. But 5 is not considered a square number because we let it get that nickname. And nicknames should be more accepted because ones like that really are nicknames. They've just become conventions. And I think a nickname that should become more common is Threven, and that should get in the dictionary. And my battery's low. I'm going to need to run and grab that. In the meantime, I want you guys to think about, what else can this modular table tell us about any type of number? And leave your thought in the comments about if this can tell us anything about the columns in my number dictionary about any other types of number. And I'll be back with my charger in a moment. And thank you so much to all the nice comments. Alright, folks, and we're coming back. And I will need to move a little closer. Oh no, my Lego tires. All right, there we go. So, what can we learn from this mod table? Well, we can learn from the fact that the diagonals only were 0s, 1s, and 4s, the quadratic residues mod 8, which we can say are the numbers that how much higher than a multiple of 8 every square number must be. Meaning every square number is either a multiple of 8 or 1 or 4 more than 1. And if we look at our number dictionary, the columns fell into mod 8, although in an irregular way. The numbers in the first column are 2 more than a multiple of 8, then 3 more, 4 more, 5 more, 6 more, 7 more, 0 more, 1 more. It's accidentally switched around because they didn't put enough thought into how I would structure it version of the numbers. And so what that tells us is that if I circled every square number in the book, it would either be in the third column, which was multiples, 4 more than a multiple of 8. It would be in the 7th or 8th column, multiples of 8 or 1 more. So every square is in the 3rd, 7th, or 8th column. We might notice patterns if we try and circle other types of numbers, like triangular Fibonacci numbers as well. And those are the type of patterns I'll show in a full episode. And I really appreciate all the comments that appreciate the birds. That's something that if I am ever gone, or even if I'm just not talking for a second and they get a chance to speak in the midst, the birds are awesome and beautiful, and one of the reasons why I like having my classroom outdoors, despite the rain destroying a lot of stuff and me having to now try and figure out how to buy or find new versions of things for grade -2 that the rain destroyed. The outdoor classroom really has added some beauty to the episodes where you get these random sunbeams and birds, and you get squirrels in some. There was another squirrel that ran by in the bonus video I dropped on this channel today, and maybe we'll see a squirrel in the stream. We also get my cats wandering around and various things. So, thank you all for the very nice comments. I love you so much. To all these super fans around right now, remember that if, or at the end of this stream when it processes, and for my last 2 streams, if anyone wants to go through and leave some timestamps of when different topics were talked about or when different activities were done, I've been trying to do that, but I'm pretty busy with other stuff this week, and I will pin the comment and like the comments that leave a good timestamp of when stuff happened in one of the streams. In any case, we are going to have a variety of topics today, and we're going to move on from the Mod 8 silly number book to some other books that I love in number theory, that some of them I've already read all of and they're very dear to me. Other ones I'm just going through and enjoying. And we're going to pick a random number to go to the page in some of these books. And we'll also pick a random order to put the books in. So we have 5 books in the stack. If the order we call them right now is 1, 2, 3, 4, 5 with 1 on the top, someone in a comment leave a rearrangement of the numbers 1 through 5. Leave the numbers 1 through 5 in a different order. And somebody else in a comment leave a number that's likely to be a page number in a book, a number between 0 and maybe 300. And that's how we're going to reorder the books, pick a random page, and sometimes randomization can be fun. It's not going to be a true randomization. That's almost impossible to achieve and is a great philosophical question as to whether that's even possible or not. But Someone said 5 factorial, and we need a rearrangement of them. Maybe you meant that there's 5 factorial ways to do that, which is true. There are 5 factorial possible answers to my question. Although there's 5 factorial minus 1 answers to my question, because I said rearrange them, so you can't say 1, 2, 3, 4, 5. So 5 factorial minus 1. That's a good trick question, you know. Got to rearrange the sequence 1, 2, 3. How many ways to do it? There's 5 ways to rearrange it. There's 6 ways to arrange it, you know. So we got page 157 and 53412. Thank you, folks. Here's what we're going to do is we're going to, I think they all have a page 157. So we're going to try 157 in each of those books in that order. And to anyone who might leave comments that are like timestamps to help me out later, this is an example of what they're useful for, is like when the different books started. So rearranging these into 5, 4, 3, 2, 1 means we have 5 first, and then I'll put the new first on top. Sorry to the other person who added a rearrangement. We're going with the first one. 5, 3 was this middle one, goes next. And then we're going to get 4, and then we're going to get 1 and 2. So this is the new order of the 5 books. Funny enough, the first one is the one that got the most focus in my bonus video, because my bonus video was about reasons why 1 can't be considered a prime. And when I discuss this in a moment, it will mildly spoil that, but the episode's still worth watching, the bonus video. There's still a lot of other thoughts I have to share about what prime numbers are. So you should still watch that, but at one part of the video, what I was discussing is that one convention that it breaks or doesn't help with, if we make the choice of allowing 1 to be a prime, is that we then can't quote this thing called the fundamental theorem of arithmetic in the same way, which states that every number has a unique prime factorization, meaning like 27 is 2 squared times, 28 is 2 squared times 7. And that's the unique one-to-one correlation prime factorization to number. That wouldn't be the case if we could say times 1, times 1, times 1, an arbitrary chosen amount of times, with 1 being considered a prime. The prime factorizations would no longer be unique. And that's a flaw this book has, is that this author, for some reason, says that 1 is a prime. It's a convention that some old mathematicians used, but is no longer the convention by any means. And this guy, for some reason, went with that he said 1 is a prime. Now, I would be okay with him making that choice if he really stuck with it, but there's sort of a contradiction, because he does try and use the fundamental theorem of arithmetic as a proof to demonstrate other things. And so you can't really use that as a stepping stone when it's not true, because you've allowed 1 to be a prime. However, this book is still interesting, and it's very playful. And, for example, the first chapter is called 7 Jogged My Elbow. And the first beginning is, every number has its character. I picture 7 as dark and full of liquid, like oil when it oozes from the ground. And he describes his opinion of what numbers feel like. It's interesting. I think I have a mild bit of what they call synesthesia, where you associate one sense with another, and I've always associated colors with numbers. I'll go into that at some point in the future, but I do have certain colors I associate with numbers, and to a degree maybe certain shapes or feelings of texture or things. At some point I'll show the list I made when I was a kid, because when I rechecked it, it held surprisingly similar to the same colors I still associated it, even after forgetting about that for a while. But this author gives his opinions about that before jumping into the number theory. But we're going to look at page 157. And someone says including -1 as a prime would also satisfy the fundamental theorem of arithmetic, but for negative numbers, not quite true, because you could do -1 times itself 3 times and get back to itself. So you'd have a prime factorization with -1 attached any odd number amount of times. So yeah, they realized that one right then. Uh, I get the comments a little late, so I just saw you realize that. But unfortunately, that won't quite work. But you could try and edit the fundamental theorem of arithmetic if you needed and said except for 1 or except for -1. But if we allow them to be primes, we're going to have to edit a lot of other conventions too. I go into some of those other rules it might break in my bonus video. But in any case, on page 157, we're going to see what's going on here. Now, oh, cool. It's talking about residues, and I believe they're talking about quadratic residues. These number theory books love that thing I was talking about called quadratic residues. So what they're talking about right here is going to be a little confusing to jump right into. But let's go a little bit back so that it makes sense. So, actually, it's not going to make sense right before this. We're going to say just what comes in the first paragraph here. Let x to the r, x to the power of r, be the lowest power of x that comes out to be 1, talking about in a given mod. Then the sequence repeats after each r members. And what this is talking about was if you're doing something like the powers of 2 in a given mod, then whenever you get back to 1, you know it will repeat. It may not be the only way, because you may have other ways where you hit a different portion that repeats. But definitely if you hit a 1, it should repeat, it's saying. Now that's in a certain context, it might just be talking about this one modular thing there. But it's funny that it is very similar to what we were talking about. They have a sequence like the powers of 2 in a given mod. I believe that's in mod 10. 1, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8. And it's going to repeat that 2, 4, 6, 8. That's not an example of the 1 coming, but we get 2, 4, 6, 8, 2, 4, 6, 8. They're including the 0th power there, I guess. But here we have a cycle we can see in certain patterns. The powers of 2 will also be in a very specific spot in this number dictionary, which I'll show when we come back to that sometime. So someone's mentioning about negative exponents of primes. Extend it to positive rationals, and we will get into that in a future episode. So I'm not going to rant about that just because it is a interesting part of a topic that will show up in early grade -2. So I'll save my rant about that for when I'm dropping an episode that includes that concept. So the name of that book was An Adventurer's Guide to Number Theory by Richard Friedberg. Now, I recommend that if you're going to get a bunch of books about number theory. It's fun enough and good enough. But some of these others are slightly higher recommendations that I'm in love with. And this next one in our stack, I haven't even read all of this yet. It's very dense, but I've learned a lot from it. It has a lot of cool little number theory concepts done in a playful enough way that delve into so many corners of interesting things. Now, let's see what they're talking about on page 157, which is in a chapter called On the Square. They're looking for formulas for things similar to which square numbers are the sum of 3 different squares. When can you add 3 squares to get another square? Now, although we're on 157, I want to go back to just a fun example of the type of stuff this shares. In passing, we might mention some remarkable relations among consecutive cubes whose sum is a cube. such as 3 cubed plus 4 cubed plus 5 cubed equals 6 cubed, which is true. It does not go up to fourth powers, but it's a mutant variation of 3 squared plus 4 squared equals 5 squared that is true for cubes. You also get this one. Apparently, the sum of the cubes from 6 to 69 is 180 cubed. So there's a good one for the meme lovers. Now, on page 157, it's kind of in the middle of talking about something. It goes really quick, and it's discussing something called congruent numbers, which I did make a short about once. Although congruent numbers is one of those terms that's used different in different cases. So right here, they're going right into this wild stuff. This is obtained from the general rule applying to all congruent numbers, where to solve this equation, these equations, you got to find the sum of these other ones, then da-da-da-da. And it turns out that this thing is true, and these are the minimum values. This one's going to be kind of hard to just jump into a given page like that. But it's a mix of like kind of playfully written stuff and these dense tables of things. So this is really fun if you want probably the most playful of the hyper-dense ones that I've read. Now, I forget if it's this one or this one, but I remember one of these, interestingly, is written, I think it might be this one, is written before they solved the question of Fermat's last theorem, proving that a to the n plus b to the n equaling c to the n is only possible when n is 2 or less. It's impossible for any exponent higher than 2. Can't have a cubed plus b cubed equals c cubed, and we're talking about for integer solutions, or for fourth powers, or etc. And so they proved that in the 90s. So it took a while for them to prove that one, and some of these books were written before that and make it sound like this big brick wall in front of mathematics that will possibly be forever there and is this giant question. Sort of like we might now discuss the twin prime conjecture or something like that. So, going to the next book. This next book I really love. And I'm about to lend this to my camera person, my camera guy, Carlo. I have various people who help me with the camera stuff, but he's the most frequent. I'm going to lend him this book just because this will help him understand some of the number theory stuff I'm ranting about. And it's a really beautiful introduction to number theory for someone who hasn't studied math as much. This book, it starts out with them just talking about the names of number roots and stuff. And I'm going to need to cite this book because they helped invent, somewhat coined, a system here that is somewhat common now of how we can describe large numbers in a structured way, like numbers like quintodecamillion or whatever, which isn't the actual name. But how do we structure those prefixes? They made some good suggestions for that kind of stuck. And a lot of the other language they use in this book, they kind of chose which language to use, and it doesn't always line up with the right terminology, but you get their point, which is the point, and sometimes the terminology they picked ended up sticking, and now is the correct terminology, whatever that means. It's written by John Conway, who is a great game theorist and played around with these brilliant games and figured out these intensely awesome mathematical things from them and invented these whole types of number. And this guy, who's also really awesome, investigated a lot of unsolved problems and various mathematical things. And I feel like I'm sort of like more of a John Conway, and I might need a Richard Guy to co-write some books with me sometime, because I have a lot of wild, playful thoughts, but I might need some help structuring them. Some of my books I definitely feel obligated to write on my own to get them exactly how I want, but I have so many ideas for interesting math books that could be written. So they go into just like the number roots, and then they jump into all of this crazy number theory, and they have some good pictures of these triangular number relationships. And like when we talk about tetrahedral numbers, we're talking about these. One moment. Where's the tetrahedral numbers? Well, here's like square hexagonal, or yeah, square hexagonal numbers or something. These are when we go up a dimension on the figurate numbers, and these are figurate numbers. And there's really cool ways of demonstrating these. And on page 157, which is the page we chose for each of these books, let's see what they're talking about. Ooh, it says it's about, this chapter is called Further Fruitfulness of Fractions. And this one is called about fractions that cycle. And this book's great because, like I said, it's a good introduction to number theory, because if you really don't understand parts of it, you can kind of jump to the next part and hope that you're not going to need to rely on the earlier stuff too much, and it might just be a new fun thing. And here's an example where we can understand this without even having been in the book. They're saying, so 1/7 has these patterns that repeat, this string of 6 digits that's starting from a different point for each of these cycles. But it's not just that. 1/13 does it too. However, there's 2 cycles that 1/13 can have. 2 strings of numbers that can possibly alternate for. And there's these wheels on the next page they use to describe these with a different type of visualization. And there's cycles for all sorts of numbers, and they explain that the reason for the cycles is due to modular arithmetic, which you know I love. Someone says we still have Conway's Game of Life, which he had so many mathematical contributions, and that's actually just one of many, even though it is the one he's most known for. But I want to save either a solo stream or a full episode to discussing the Game of Life, because there's an online interface I'll use, and I want to make sure that I like cite the people who made it properly. I know it's like Creative Commons if you cite them correctly. And then I want to use the actual interface to be able to, in a video, show you guys patterns in the Game of Life that go really crazy. And let me see if I have the pentomino that goes really crazy. Oh, I don't know where that one is. So these pentominos are these little connectors of 5 cells. Oh, it's this. Okay. This pentomino. The Game of Life is this thing where you start with cells on a grid, and there's rules for which ones recreate or are born and which ones stop being there or die, and it's just a 2-colored grid, and each phase there's rules for which ones turn on or turn off or stay. And it's a simple set of rules, just a few rules, like if you have this many neighbors you do this, if you have that many neighbors you do that. And some little strings evolve into a little cluster that dies or sticks to something or floats off. And some of them take a long time to hit some weird thing they create. And this is one of them. This is like the simplest shape that you can make there that goes crazy. And we will do a solo stream or a full episode about that to observe it. So, someone's saying 2023 is hexagonal number. Is that true? I know 2024 is a tetrahedral number. Where's the hexagonal numbers list? Good old OEIS. No, it's not. I don't know who's saying 2023 is a hexagonal number. That's 2016 was a hexagonal number. However, if we go to tetrahedral numbers, we can see that, let me shrink myself. I've just been clicking some of these things. Oop. So tetrahedral numbers are when we stack triangular numbers. We can view the tetrahedral numbers a few ways. Like, I'm going to erase my mod thing. And one of the ways we could view them is that if I take a list of the number 1, and then I take the collective sum of this, 1, 2, 3 has happened, 4 has happened, 5 has happened. I'm adding up how much has happened so far up to a given point. Now if I do that again, that's the natural numbers. Now if I do that again, I'm going to get the triangular numbers. And if I do it again, and in a way it's a different diversion of the factorials, because if instead of adding at this phase I multiplied, I'd get the factorials, taking a collective product. But a collective sum led me to triangular, and a collective sum of those leads me to the tetrahedral. And we discussed those a bit in one of the weirdly broken in half by my internet and YouTube streams that we did last night. So someone's saying if you plot a hexagon with 3 dots on each side, you can have 23 dots. Maybe you're talking about something like a centered hexagonal number. That is a type of thing. No, it's not one of those. So yeah, I'm not sure what you mean. Maybe you have a way of drawing a hexagon like that, but I'm not seeing any like this. So someone's wondering what time it is, and it is 11:42 a.m. here. I have some plans in the evening, but my only plan today is to do some fun streaming with you guys, then maybe try and do some writing or editing. Already did a little filming of a bonus video that's in this description. Now, while we do our next chat, well, no, we have 2 more books. Let's do 2 more books before I get diverted. We're looking at page 157, was randomly selected by someone in a randomly ordered stack of my number theory books to compare and contrast them. And this next one is pretty dense. I would recommend this as a more textbook-like one for someone who wants a lot of exercises. Maybe not my favorite out of the batch, because I do like the creatively, slightly almost verging on recreational mathematics ones. But this one is a bit more textbooky, tries to make you do a bunch of the work, contains a lot of proofs of things. But it's going to still contain something interesting on page 157. And it says, alright, it's going to be hard to know where we're jumping into, so we're just going to read it. We see that 1, 4, 6, 9, 11, 14, 16 are the first 7 elements of S2. So far, these are all the numbers 1 unit away from a multiple of 5. Thus, we may conjecture that S2 consists of all positive integers congruent to either 1 or 5 modulo 4, back in Modland. We shall see in chapter 14 that that is indeed correct. All right, so then they go into more stuff. Once again, talking about modular arithmetic. So now for our final book that I had in my stack out of my many books that could be described as number theory books. So some comment, by the way, says, what about the number 6174? Google says it's the most unique number. I'm not sure what Google decided about that, but it is a good number because it, in our base, has this interesting property that I'll cover when we cover these cycles of these Capricar-type numbers, as some of them are known. But although it's more known as Capricar's constant than the numbers itself. And we'll go into those. They have interesting cycles, but as usual, that one's a little base-dependent, which makes me want to compare it to the ones that happen in other bases. So the last book that we had in our stack is called Number Theory and Its History. This one I have not read much of yet, but I really like it so far. Now, if anyone wants to join me in reading more of these, let me know in a comment on one of my streams or my full videos that you want to start reading one of these with me, because I will be reading them, and we can have a book club. So, in this book, page 157, which the funny thing is I haven't read up to this point yet, but I'm not really worried about spoilers in a book like this, because if it's a spoiler, that I actually understand how it's a spoiler, then that means I learned something new, and that's totally okay, because the order you learn things doesn't always matter. So, in 157, let's see, they're in the middle of something. For several unknowns, the situation's more complicated, as we've seen from the examples in Chapter 6. We indicated how one could find the general solution by a series of reductions, and this method is probably the best available. Let's illustrate it by da-da-da-da, and then a bunch of math. And then, if we see the next train of thought they have, say classifications of systems of numbers. And they're saying what types of numbers will describe as different sets. So that's quite interesting. They're delving into set theory a little bit there. And a lot of interesting stuff. So these number theory books have a few things in common. They really like modular arithmetic. They really like prime numbers. They really like, let's see, a lot of the stuff boils down to different forms of modular arithmetic, but they also like a variety of types of number. It's mostly concerned about types of whole number, and sometimes it verges onto complex numbers and other types of rational number or irrational number. But it's especially interested in the whole number solutions, and there are certain types of equation, a big grouping of them, that of the equations known as Diophantine equations that they're trying to solve in a lot of number theory questions. This type of equation that finding the integer solutions to these is a common quest. We could call Fermat's last theorem one of these. Let's see. Yeah, that's this example is Fermat's last theorem. Right here. For n equals 2 as the exponent, there's infinitely many solutions. For larger values of n, for larger integer values of n, Fermat's last theorem states there are no positive integer solutions. And that was proven. They say in 95. I think he got most of the proof before that, and then it required a little edit. They got it finished then. But look how long it took. Initially claimed in 1637 by Fermat. So, someone's asking if they can borrow the book from me. No, they can't. But they're really cheap. I don't have money to buy new books. Even practically, books have gotten expensive. All these books were the ones that happened to fall in the Venn diagram of looked interesting and trustworthy, and I could get for less than $10, including shipping online. So I get used ones. So you're going to need maybe to spend $8 and get one shipped to you, but you can find used copies of a lot of these books. You can, of course, also find digital copies if you really need, and I'm not against that. I'm not going to recommend it, but I'm not like adamantly against that. But I will say that even apart from supporting publishers being good, it's good to have a paper copy. Puts you in a meditative mood. There's plenty of studying to do on the computer. This type of studying, if you do it in a paper book, gives you a different, more well-balanced feeling. Just the way your body digests it. Someone's asking would I choose algebra or geometry, and I would not like to make that choice. Pretty impossible. I'm really into more of this number theory is more algebraic than geometric, although it relates to both. So I would say for now, if I had to pick this year, I'd go with algebra, but I could have years where I'm more into geometry. They're both pretty awesome. So these are really interesting, and looking for solutions to these that are integers is a common quest, and some types of them, I was going to say, that if you find the rational number solution that works, of any fraction even working, you can scale that up to integers that work by multiplying the fractions by something. Not all of them work that way, but some do. And some of them, that means that if you prove that you can't do it with integers, it also proves you can't do it with any rational fractions. Because if you could have done it with the fractions, you could have scaled them up to an integer solution. So if you prove there's no integers, some of these you've also proved there's no rational solutions. So someone says they have a dice math combo about how many combos of faces you can have with numbers 1 through 6 with an all ones sided die to an all sixes sided die. Well, to find the odds, I would just make a table that looks like my mod table, where one die's axis is 1 through 6, one die's axis is all ones, and you fill in the blanks. And that'll tell you the options, and it'll also give you access to like looking at the average or to the mode or other ways of calculating average-like things. Someday we're going to do an episode about different types of averages, because there's not just like average, median, and median and mode and stuff. There's a lot of types of, even within just the word average. We assume often that you're doing an arithmetic type of average. Sometimes we assume some things like a geometric type of average, and sometimes more useful to use other ones, like there's even this, the Pythagoreans considered there to be 3, and the third is this harmonic average. And we'll do an episode about all of those and the other types of possible averages sometime. Someone said my face isn't in frame. I will make my face grow. I had it extra shrunk for some stuff. Sometimes I super shrink it to watch stuff. Like we were watching some sneak previews of the next episode and some behind the scenes. For any newcomers who want to rewatch this chat later, there were some fun sneak previews and such. So, someone said geometry is Stone Age, people. And while geometry is still super useful and still has a lot of open questions and a lot of cool progress, it is true that geometry was overrepresented in certain times of the past, because certain old mathematical eras and structures treated numbers like lengths, treated proofs like proving things about what happens with shapes. And so that prevented them from looking at certain things that had, for example, a fourth power in an exponent. That's kind of hard to represent with geometry. So geometry is really good at certain things, but one example of its limitations are that it's really good for humans at describing the first, second, or third dimension. And what if we have something relating to fourth powers, which is sort of like talking about the fourth dimension? Then kind of hard to do that with geometry. Fifth dimension would be even harder. So, that was some fun random thoughts and looks at books. While we do our next activity, we are going to get out that Lego, because it is Lego or International Lego Day. And so, sorry to the haters who think this is childish. Part of combo class is about deriving the mathematical fun and some of that pure enjoyment out of activities that one may consider childish, because although children can be quite dumb in certain ways, there's some ways in which their curiosity and other traits can be inspiring. Someone asked if I like calculus, and I do. Calculus is at the heart of a lot of modern mathematical learning, and we haven't done many episodes or shorts that related to it yet, but we will at some point. I want to, do a good presentation about calculus and some of the topics like that can go quite deep. I kind of save until I'm ready to do that depth. And for the rest of grade -1, that'll be Pandigital numbers, like those crazy ones, infinite series, this mix of language and math one, and one open spot that I'm leaving, for, I have way too many ideas to fit, so there's plenty I can put there. Or if something crazy happens here, like lightning strikes or there's another flood, then I have an open spot for an episode, because I want 36 total, the base 6 100, and then a long finale that we're going to do, a long behind the scenes finale, and that's going to be most of the main channel content in March is going to be a super long finale, because grade -2 is coming in April. It's coming on April Fool's Day, unless this is all a prank for April Fool's Day, maybe it doesn't go to grade -2. Maybe it goes somewhere else, and this is all a setup for an April Fool's Day prank. But with that said, grade -2 starts on April 1st. So, we are going to be building this Lego while we chat about a few things. And feel free to ask any questions, because otherwise I'm just going to go on assorted rants about things. Now, where did those instructions go? Oh, here. They are all here. Okay. Now, what we'll do for fun is, why not in the background for now put a graph until we have all of our topics and stuff set up. We'll have a few interesting visual stuff going on. And we'll try one of the mod ones again, and we're just going to try something super random. We'll try we'll try the square root of sine of y in mod n equals the sine of the square root of x. How about that if we flip them in n? And we get these guys. And what if we said less than and equal? Now, I know I'm really big, but I'll put them over there on this side of the screen. Ooh. Whoa. This is interesting looking. All right. What if we had said tangent? All right, I'm getting distracted though. This is dense. Maybe I need to grow it with this. Oh, that changed it. So there's these weird waves and an infinite glitchy part. And then some of the waves over here are curving down into this checkerboard-like pattern. Look, when I go small, it looks like a checkerboard pattern almost, with like diagonals. And then you can zoom up here and see where they came from. And they came from this infinitely glitchy area. So, we'll leave that in the background for now. And let's look at what our instructions are, just to see which of these bags I need to open, unless it's all of the bags. Because sometimes they make you do them one at a time. Sometimes they don't. And we will be doing some fun chatting and math. Don't worry. This is just to have a fun little meditative activity to celebrate International Lego Day. So, it looks like I need this L-shaped piece. I think this is the first bag. We'll go for this, the big one. So, I used to play with Legos a lot as a kid, and then I stopped for several years, or many years, as a lot of teenagers do. And then, one thing that got me back into it, although I already had somewhat of a continued love, because my brother likes them a lot, one thing that extra got me back into it was me and some of my friends were at a cabin trip and stocking up on some supplies at a store nearby. And we were like, what if we just got some Legos for while we're partying later at the cabin? And we got some Legos, and they turned out to be surprisingly fun. And I was like, kind of got them as a joke, but it was genuinely fun. Now, they're expensive, and they're plastic, so I'm not going to buy them much, but we got one here that I had from, I forget where I got it, and so might as well build it. Someone's wondering if we put pi somewhere, and pi might neutralize the signs. So if we said like sine of pi times that. Ooh, that's kind of cool. But yeah, if we just said like sine of pi y, let's see what happens times sine of pi x. Well, pretty complicated. Oh, now we're at a different scale and it looks different. Okay. So it's waves, like an ocean up here. You see there's waves. And then when they get to each other and then they collide, they cause chaos. Yeah. That one's interesting. So, I'm going to be fiddling around with this while we chat. And let's try and see if we can get an angle where it's all visible, which won't be super easy because I am just using my computer's webcam for this, which isn't top-notch. There are better webcams in the biz, which I have one, but I'm worried I broke it, and I need to test it out before I do it on a live stream again. So, let me think of what I'm going to chat about while we do this casual construction. Well, let me chat about wrapping up grade -1. What's going to happen here? Because we're getting quite close to that. And a lot of the stuff that happens in the transition, which will be like a clock hitting midnight, and then you go back to the numbers called 1, and it's going to be like a modular cycle of sorts, will be hidden from you until you see grade -2 appear. Because I'm going to do most of the filming in February, and then in March I'm going to have to totally clean up this zone because the rain made it completely chaotic. And to whoever asked what's in my hand in the comments, it is Legos for International Lego Day, because we're doing that as a silly meditational activity while we chat in today's stream. And so there will be a finale about the process of switching over that will also include a lot of bonus content, a little of which I've put on Patreon already, and some of which I'll continue to, and some of which will be in the finale, where we look at the process of making grade -1. Because 1 year ago, there was no combo class footage online of any sort. And now there's all sorts of stuff. There's not only the combo class channel and the combo class bonus channel, or Domotro channel as I sometimes call this one. There's also now a imposter channel, as I went over in one of my last streams, called Combo Class Bonus 2. And they're not me to anyone who sees that, but maybe I'll refresh and show where that's at again in the stream, because there's an update on that. But warning that I allowed my fans as a gag to create any combo class bonus, some weird number and some weird word thing. So any channel that says combo class bonus and not, and the one that just says combo class bonus, of course, is me. That's what you're watching. Anything that says combo class bonus and then some numbers and other stuff is a joke. Or is this one kid who named it that for some reason to get views, maybe? I don't know. So we'll go into the updates on that at some point. In any case, the process of making grade -1 was insane because not only have I gone through like a lot mentally and a lot of crazy stuff, and like my room flooded shortly before I started filming and a lot of crazy stuff, but I had to get 2 hip surgeries this year. I'll show you x-rays in the finale that my hips now have ceramic in them and titanium. I'm a ceramic Borg and a cyborg. And so that did make some of the filming hard, and I have some behind the scenes that I'll show where with the first clock I burnt and some of those times in the first episode, I was extremely limping. And I even, in some of the episodes, right before or between those surgeries, I was using a golf club as a cane, and it's sort of a subtle background gag And I actually would bring that golf club to parties as a walking stick and a conversation starter that's better than a normal cane. And as a joke for any intruders, although I actually just used it to walk with. But the walking stick, although I was using a cane in a somewhat silly way, I needed to use something. So the cane wasn't really a joke because it was actually a decent walking stick. And I'll show more details about that. And we're going to visit a place in the finale that I've wanted to go for a while, which is a big sundial at the marina where I used to go all the time. And now I've only been able to take these hikes at the marina area not far from me where there's birds and nature and stuff. I haven't been able to hike out super far, and now I can again, now that I got ceramic in me and I'm mostly recovered and stuff. So we're going to take a mission to a place I used to go all the time before I ever even started ranting about clocks and collecting clocks. It's a big sundial. And I haven't been able to go there in a while, so it'll also be a very refreshing back to my roots time, as well as tying in with my new clock collection. Someone said, why am I not focusing on one channel to make it big? Well, I just want to get the names Domotro and Combo Class wherever, and part of why I like to have two channels. One reason is I separated it at first because YouTube used to put the shorts on the main page and really clog up where the videos were, and now they're better at separating them on pages. But I still like having them on two channels to a degree because I like having one channel that's more like my TV show where I put out my finished ideas, which is my Combo Class channel. And that one's like a teaching resource or a TV show or just like my finished little passion projects. And then I have a less perfectionist channel where I can just put out things I'm interested in, whether it's like a bunch of shorts one week or a bunch of live streams one week. And this channel I'm much less perfectionist about, and it has just much more quantity. And because of the shorts, it's gotten way bigger than I expected. And I'm probably going to rename this channel at some point just to Domotro, which is it is at Domotro as the handle now that they've done that. But it's called Combo Class Bonus because it started as just the shorts. But I'm going to be putting out more personal stuff on this channel, like some music, for example. I have a bunch of songs that I've been working on finishing that I'm going to put music videos for on this channel. So this channel is sort of more like the Domotro personal channel. And then you get my TV show channel, kind of, which is, or teaching resource channel or whatever. Although I guess some teachers might like to use the shorts. The biggest teaching resource would be my full episodes. And so I like to separate them for that reason. However, I might start putting some shorts on the main channel in grade -2 or in the break between grades because the shorts do attract a lot of attention. So I'll see if there's a chance that in this next year I might start putting some of the newer shorts on the other channel just to make sure everyone knows about it. Both channels do good in their own way though because the algorithms are somewhat separate. So this channel also has a lot more viewers that are like less diehard viewers. The other channel has fewer viewers, but they're almost just as important because there's more of them who watch every episode and who are on the Discord talking to me and stuff like that. So, I don't know. We'll see to what degree I use the channels for what things in the future, but you can expect that one to more so have like a long, awesome episode approximately once a week, and this one to have a bunch of random content that happens to include the shorts currently, which is why it has so many more subscribers. So, and thank you all for chatting. I'm going to get back to the Legos for a minute and mention that in the finale, we're also going to need to do some sort of destruction ritual, which could involve fire to a degree, but some sort of destruction ritual of some of the things that got destroyed by the rain. And that's because some of these things need to be replaced, and some of the things is just their time to go. And when anything gets donated to the Combo Classroom, I let people know that it's probably going to get shattered or burnt at some point, but that I'll try and make sure it gets documented on film to have a historic way it goes down, and that I think that'll give it a more historic role than if we were to just let it sit on a shelf and survive forever. And so, to give it a more historic role, some things are going to have a little cameo in a destruction ritual, and then in grade -2 we'll replace them. For example, the remainder of the desk, which is now like a little stand that I keep stuff on, but was once the desk. And that was one of the things the rain claimed, because the rain decided water was going to be one of the major themes of the episode. And so, as the rain decided to claim that, we the desk broke in one episode and then got extra more shattered. And so, at this point, we're going to need to find a way to fully destroy the rest of it in a historic way that gives it better credit than letting it sit somewhere. Although maybe we'll keep a small chunk of the desk for memories. This is confusing. It like jumped an instruction, it seems like. That's weird. Oh, it's because I'm using this last one I built. Where's that last one I built? It's surprisingly hard to do this while staying focused on talking about something. But in any case, like as usual, feel free to ask me any questions. Otherwise, I'm just going to tell some life stories. I do have to run to the bathroom in one moment. That'll be quick. But I forgot to do that when I was grabbing the charger. So first we're going to connect a few little fellas right here, and this is going to take a while I do it while I'm chatting. But at the end, we'll either have part of a car or a whole car. We'll see. No, that one doesn't go on first. This one goes on first. And let me leave you guys with some interesting thoughts before we finish. I mean, we're not going to finish. I just have to run to the bathroom. But I'm trying to get this thing right first. It's weird. That goes through there. Okay. What? Okay, maybe I did this thing backwards or something. This goes through. No, I guess it's just at a weird angle in their picture. Okay. This is going to go through there. I'm hoping this is right. Their picture's at a super weird angle. And then this is going to go through there. All right. Sometimes they have funny warnings. I'm seeing if they have a funny warning anywhere. Maybe not. Sometimes they're like telling you funny ways of telling you not to swallow it and stuff. I guess that's for the ones with the younger age bracket. So I'm going to run and hit the bathroom really quick. I'll be back in a moment. You guys can enjoy the birds as usual. And since I have all these Pandigital numbers in the background, I'll leave one of the questions again. That the deepest question. Oh, hey, Sage. My cat Sage is coming. Maybe he'll keep you company, unless he follows me. Sage, you're magnificent. Oh, Sage. He likes helping in the classroom. Sage. He's just hanging out over there. So maybe Sage will keep you company while you're out here, and the birds certainly will. I'll be back pretty soon, and out of the two questions I asked about Pandigital numbers, one of them that's really at the heart of the episode is, what would you learn if you tried to find ways of describing how many Pandigital numbers are, or what percent of numbers are Pandigital? That's a very deep question that's at the heart of the episode. But first it's going to touch upon, as we're in other bases, just as sort of a more fun fact or interesting thing to ponder, what would it mean to be a Pandigital number, or to not be a Pandigital number, in binary, in base 2? So somebody, if you want, leave a comment while I'm gone, or you guys can chat about this. What does it mean to be a Pandigital number in base 2? I'll be back in a moment. All right, folks, and we're back. And nobody tried the challenge question. That's okay. If any future viewers want to, they can leave a comment. It will be answered in the episode about Pandigital numbers coming on the main channel in a few days. Now, what we're going to do here is a fun game, I decided, while I build these Legos for International Lego Day and occasionally switch our graph around. I'll tell some stories from the combo class past of what I know. And Sage is back. He likes following me and helping. Of what, do you see him back there? Let's see if we can get a Sage view. Sage boo. That's a little Sage. That's a good boy. He's very curious. Sage. That's a very curious boy. So, we're going to play a game where I'm going to tell you some stories from grade 0, which is the whole combo class past. And that continues way back into the past to when I was born, or arguably earlier. Grade 0 is maybe infinitely long. Who knows? Because 0 is an insane number. So, what we're going to do for our game is you guys are going to comment an age. And I'm going to tell you some story that happened when I was approximately that age that might relate to our combo class lore, or just at least it will relate to the Domotro lore. So leave a comment with some age, and I will tell you some interesting story that occurred around that time. While we sometimes change these variables and stuff, and we also build this for the International Day. And I'll adjust this a little bit so we get less glare. Now we're going to be in a less glary zone, even if we don't see as many clocks. And let's get a view where we can see the Legos as well. We got 17 and 24. So, I will do those. Someone's noting first a fun fact about Sierpinski's triangle. And I do know that. In fact, there's a good animation from that from an animator I befriended who runs a channel called Math Letters on TikTok and also wrote a book about that. And so I may include his animation because he said he's down for me to use animations of that stuff in one of my episodes, because I discovered a pattern myself that one of my viewers is helping me investigate in programming, that this pattern relates to Sierpinski's triangle and a deeper type of web that I discovered. So I've discovered it in a pretty wild place, that pattern. Oh, and you said he is your friend as well. That's cool. Yeah, I've chatted with him, and he's down for me to use the animations at some point in an episode, and I might use his animation of that as a cutscene when I discuss that, when I'm talking about my own thing that's called my Pond Forest sequences. So, while I'm building this, I'm going to discuss some of the lore that occurred at those ages. Now, first going back to 17 was noted. When I was 17, I was a senior in high school. I had been 1 year ahead in math before that. And then I decided, even though I loved math and loved studying it on my own, I decided instead of taking a college level math course to use my year aheadness to have a free period, which was an option. So I didn't have a first period on my senior year, and I was able to just have a class on my second period because I had been a year ahead in math, and I just used that as my gap and then could study my own stuff instead for that amount of time, or sleep in, And then my first period I would often be late to, because honestly, and of course this is just to have the combo truth and not for people to copy, during that year I skipped a bunch of classes, and that was because I was more focused on some other activities in my life. That some of them were creative, such as I was doing a lot of music, and I was very into producing my own hip hop beats, which at the time I was using a lot of samples from cartoons to chop into beats and then rap over them, which I've done various types of music at various points in my life. I was also into making rock songs and various stuff. And so I was kind of sidetracked with that and some other things that I'm going to have to wait until future grades to tell you about, because, I got into quite a few shenanigans, but I managed to still get all A's and B's. And that's because although I cared more about my learning outside of the school and reading books and writing and playing music and stuff, I still wanted to play the system good enough, because you need to get good grades in order to function in our society for jobs and random stuff. So I managed to play the game good enough to get only A's and B's, and in middle school, I'll tell you a funny story about this, but I got pretty much all A's except for one B+, which is sort of a funny picture. I guess I'll come in frame, and then you can just see the Lego when I hold it up. You don't need to see them on the platter. So it might be really sunny. Let me adjust it to somewhere where it's less sunny. Yeah. So in that year, I would come late a lot. I forget if this was junior or senior year. I'm going to have to look into it. But when I was about 17, one of the classes I would come late to a lot, the teacher was a lot more strict on one of the 2 semesters, because I had a different teacher on 2 of the semesters for what was my second period after my free period. And that teacher was strict, and I had to be on time more. He tried to call the house once and left a voicemail that I deleted. And then the other teacher was a little less strict, and he was a really wild guy who everyone has a story about this teacher, something crazy he did in their class. And it turns out that I know even crazier behind the scenes stuff about him, because his daughter was dating my friend, and I like was friends with his daughter for a while after I had his class, very separate. But this teacher seemed to like me. He knew I was good at tests and essays and that I wanted to learn. And so he worked with me on my always coming late. And there was one time I missed a test. And then he said, "Oh, you're going to have to." And I think he was trying to just like put me on the spot to embarrass me because he liked to like make the kids do crazy stuff that like I think is pretty funny, but some people would be offended by like some of the wild antics he did. And he was like, "All right, you have to act out this weird thing we had been studying in front of the class like a play because you missed the test. And then I'll make your test grade how you act out the thing." I was like, okay. And although I was really nervous and I still do have some social anxiety, I've gotten good at overcoming stage fright, even though I still get it. I've gotten good at overcoming it. And so I did like some good performance about what we were doing. And then I got like an A minus on that as my test grade. And then I realized this is a good system. And I started purposefully missing some of the tests because you would always have some other activity for me to do for my test grade. And those were always easier than the test. And I ended up getting an A in his class, I think. But there was a lot of wilder stories during that era that I'm not going to be able to share quite yet. I'll share them in a future grade, but one of them that's more mild is that I had been releasing a lot of music in that era, and I actually burnt a CD of an album I made, which I was referring to as a mixtape at the time, pretty much just because it had all these cartoon samples as opposed to as much of my live music. But technically it was just like an album with samples because it was all original songs. And I handed it out really embarrassed, but making myself do it for like I thought it would be good for me, and it was good for me. Handing out this CD I had made of music under an older different artist name to a bunch of people. I burnt like 30 copies, including some of my teachers and a bunch of random classmates and stuff. And I'll show you guys that CD at some point. I have a copy around. So that was some 17 stories. And the other age we got was 24. So I think I got this step of the Lego down. Apart from I need one or two. Okay, this step's good. We're on to that step. And now I'll tell you a story or two about when I was 24 was the other one we got as a random number. And when I was 24, I was working at a music shop. And I'm still really good friends with the owner. And at some point, when I film my music theory lessons, which in grade -2, I'm going to do a bunch of music theory lessons about how piano and guitar and other instruments I know relate to cool mathematical concepts. And I even am going to redesign a broken clock, possibly this really big frame. It's all the way back there, but possibly that really big clock frame into this musical thing. And it's going to demonstrate how the musical scales relate to all sorts of math stuff that's fun. And I use that to teach music, and so that not only will you see some cool patterns, but you'll know like some cheat codes, Domotro style, of how to play piano and stuff. So when I do those, I'll probably do them in this shop. There's 2 shops of it, so I'll do it in one of the shops. And I'll check with the boss if she wants me to shout her out and see if anyone in the area needs like music instrument rentals or whatever. But when I do that, we'll film our music theory lessons when there's a good time for her and I'm in grade -2 and stuff in the shop after hours, because they have tons of instruments, and we can do the music theory lesson on like, here's a wall of guitars, let's grab one and play some. Here's a wall of pianos, let me show you something. So that'll be fun. And I was working in this music shop, not in the location we'll probably film at, because there's a newer location we'll probably do the filming at, but in this other location that's kind of far from my house. And in the Bay Area, there's the big transit system that goes all the way around the Bay Area is called BART. and I would have to take that on a few different connections to get to the shop. It was a really long commute. It took me probably an hour to an hour and a half, more like an hour and a half, to get from my house to the shop, because I had to walk to this BART, public transit train station, take a train, wait for a transfer, take a different train, walk from that thing to the shop. And so it took like around an hour and a half a lot of the time, or slightly under an hour and a half each way. But it was a cool job, and I was still figuring myself out and going through a lot of weird mental stuff, and there's a lot of chaos and turmoil in my brain and my life at that point. And some of those stories, once again, have to wait for a future grade. But I will note that around that time was when I had been just managing this tiny music shop, that I was running the retail with just a few other people, and I had been there the longest, so I was like unofficially managing it. And it was a really small shop, kind of fun, taught me a lot about how you would run a business and how different little things work. And so I learned a lot from that. And I realized, though, I don't want to do this forever. I was more interested in the music teaching that I saw certain teachers were doing at the shop. And I started easing into transitioning to some of my time there being music teaching as opposed to running the retail. And before long, I realized I liked that a lot more and transitioned fully to that. And looking back on it, it was definitely a step toward what I do now, which is some sort of weird teaching in my art. And so before these videos, I had, and I still have students privately. I separated from the shop, but I have some private students. And I separated very amicably. The boss is super cool. And so a big part of the transition over here was me going from running that retail to switching to music teaching. And now I still have some students on a variety of things: piano, guitar, ukulele. Some I even teach beat making techniques too, songwriting techniques, and a variety of things. And although I try and also just give them some sorts of typical practice, my teaching is different than average, and so my music theory lessons will be interesting. So, someone says they have an idea for a clock. It's a 24-hour clock, but starts at 24. That could be good, and that's basically just like the military time clock, but I've thought that would be good on the thing. But I want it to start at 0, because 24 then is like 24 and some change. Our clock similarly goes from 1 and some change to 12 and some change, instead of it being 0 to 11 and some change. Can I sing a song right now? I'm not going to sing a song right now. At some point soon, I will release some music that involves rapping that is sort of singing like. However, because I've written many, and there are some I've written on my Patreon for the higher tiers. I put out a link to like this, all my old projects under one name, that I'll show you guys at some point when the time is right. And so someone also asked, do I know Kevin from Vsauce? And I do. He's cool, from the Vsauce 2 channel. I've watched some of his videos. I like the ones about like mathematical games and paradoxes. And yeah, we'll switch this around a bit. I don't think it's going to allow I. It doesn't really do that. I would just treat it as a variable, because we would need another dimension to make I work on a graph like this. We need 4 dimensions to make I work, the input of this and the input of that and stuff, and the output of each. But we can change this to other fun stuff. For example, what if we just have the square root of y times x is less than that? We get these weird blocks. And what if here we say times y? Ooh, we get a weird ripple thing. Look at these strange curves. These are cool. Whoa. It's like melting through itself. That's cool. Oh, it went over here. Okay. So, I'm going to go back to the Lego, but if anyone wants to ask any other ages, they can, and I'll tell you any more combo lore. And yeah, it'll accept sign of E, but that's not going to be as crazy as X, because E is just a number. That would be like saying sign of 2.5 is approximately the same thing. So, here, let's see what else we could try. We can try X squared. And this one we're going to simplify. Let's say Y squared. Even that's crazy. Where's 1? Okay. Wow, see, this is really crazy. These are the coordinates where X squared in mod 1, which is like X's fractional component, is less than or equal to Y squared in mod 1. And I could distort it if I make this one like 2 or something. Okay. And if I make them these, we get weirder stuff. Ooh, that's cool. Alright. That'll be our symbol for now. Someone asked if I could predict the world population. Probably not better than a computer, but I can give a rough guess. 50 years from now, there will be 8.5 billion people. How many are there right now? 8? Or more like, yeah. So there's about 8 billion. Yeah, 8.5 billion. But I don't know. A computer can probably guess that better than me. So, any other questions, feel free, or even another age you want a story about. In the meantime, I'm going to jump back to our International Lego Day thing and build another one of these little guys. Sometimes you got to build things that look like nothing before they come together into something crucial. And that's one of the fun things about Legos, is they show you different ways that shapes could combine, sometimes making a mini component and then making a mega component. And let's see if we can hear any birds also, because the birds, of course, are really beautiful sounding, and they've quieted down right now, but maybe if I pause talking for 1 second, the birds will continue. We can hear them in the background. You guys should have seen the fog this morning. It was super crazy. When you woke up, well, I woke up early and got outside, and it was like this weird blanket over like everything 20 or 30 feet from me looked like it had this blanket from me. So, someone says 12 a.m. equals 24, 1 a.m. equals 23. Yeah, but it still just doesn't work as well in the mod cycle, because it's just like, why go from 1 to 24 and some change instead of going from 0 to 23 and some change, and then the reset happens at 24. Our clocks are built super weird. And of course we'll do more clock episodes, because I even need to go clock hunting soon for the clock quest. I definitely need to restock some clocks. Some have gotten destroyed by the rain or by other reasons. And so during my next little period of transitioning for grade -2, one of the activities is going to be to visit some thrift stores, as well as possibly some stores that specialize in clocks, and see if I can get any deals. I don't have a big clock budget, but I'll see what I can make happen. If I befriend the right clock shop owner, I could tell them I'll be their best customer for life if they cut me the right deal. So this is kind of tricky to get right. Let me make sure I got this right. I didn't. I put this on backwards, so let me fix that. It's kind of hard to do this while talking, actually.
Seems like it would be easy to just do the Lego, but there's so many pieces you got to put on in a correct orientation that whenever I'm chatting, I realize I put on the piece wrong. So, still very fun. So, thank you to everyone who's still sticking around for this quite random stream. I doubt we're going to get the entire car built. We can also move on to some other activities in a moment, but the main topics for this stream were mostly focused on looking at a few number theory books that I had mentioned and going through a few stories and a few plans. But we'll see how long the stream continues, because for now, I shall continue the casual stream while I build this Lego. And let's see. About the clocks, let's see. Someone says 2 a.m. is 22 and stuff. Huh. So you're starting with PMs. So the clock will tell you how many hours are... Oh, it goes backwards and it tells you how many hours are left. That's interesting. So that is a new idea. If the clock went backwards and told you how many hours are left in a day, which is a cool idea. You could try and invent that sometime. And we do have a recommendation for one here as well, which is y equals x times sine of x times cosine of y. Ooh, yeah, that's a cool one. Let's do less than, too. I think we've seen some like this before, kind of maybe a sideways orientation, but these are super cool. And we can adjust this, of course. If we put a variable in here, we could try some stuff where well, that just grows them if I put it in both. Let's see if I just put it in one. That stretches it. Now, we can also try, what if instead of multiplying by the x, we divide by the x? Oh, that didn't do anything interesting. We had to multiply by the x. What if we put a sign on this side? Gives that wave. And of course the question is, what if we try tangents? Because those are always weird. Alright. Sine is actually the coolest so far. This is actually the coolest mix, was sine and cosine. But what if we try square root of x in there? Ooh, that's trippy. Blobland. Oh, Dustland. Can't comprehend this one. Yeah, I can't comprehend these ones. A lot of these is having trouble comprehending. Oh no, I'm just too zoomed out. Okay, we gotta get back in. Back to home base. Maybe some of those worked and I was just too zoomed out. This one's weird. Now we get a sort of diagonal blobland. Alright, what if we put the circle-like equation in one of these? X squared plus y squared. And take the x off. And what if it's the square root of that? And not getting anything too wild here. We need to stretch it more. Now we got these fronds. Those are kind of cool. But yeah, there's a variety of cool ones we could do.
we're going to go back to this, and the other test we're going to try is a mod 1. Whoa. We got bumpy hills. Whoa. That one's cool. Okay, look at this. So when we're at here, a really low value, it seems like they're like not bumpy hills. They look like these ridges. Then as we go forward, they start to crinkle. And look, it's getting these double layers. And it starts to do this weird bulbing down. And it's getting really bulbed down. And it's forming an infinity in the middle. Ooh, and then it turns to eyes. Get your infinity that melts into your eyes. Oh, and it makes another. It keeps going. Oh, I need to set this to be able to go higher. Let's see. Ooh, look, yeah, it keeps generating infinities then eyes. Isn't this trippy? It keeps dripping as I go up. That is crazy. Keeps going. Alright. So, someone said put x squared sine x cosine x. We could try that as well. So, we'll take out the mod for now. They said sine x cosine x. This one's pretty cool. We're going to go back to the mod and try, and we're going to try the mod of y. And can it handle x? Whoa! That one's weird. And if we say mod n instead, well, they came back. Alright, these ones on the side look sort of like a Christmas tree, and then you got these hills. And someone said cosine y actually, but we're already in this weird land. Oh, I like this one. It's one of those ones that turns into a checkerboard on the side. But then you go close and you're like, what the heck? Here you're like, oh, this is a boring checkerboard. Or is it? So, we can adjust the inside with these weird infinities and eyes being created. These look kind of like faces. Look. Do you see these faces? You got like eye, eyebrow, and like mustache or something. Lots of possible faces being formed here. Whoa. Crazy how it mirrors what natural selection did. So someone wanted to try this other one that had one thing switched, where it was x squared sine x cosine y, and it looks like that. Yeah, that is cool. It's one of the ones that becomes a grid. So yeah, that one's pretty wild. What happens if we add a mod thing to this? We can melt the inside in different ways. Ooh, they sort of touched and became more normal for a moment, it looked like. Yeah, near zero, they get closer to normal looking, but then they turn all weird.
That's pretty wild. Whoa. This is a weird bug. Alright. Now everything's clumped around here. Oh, it spreads when you go out. Wow. Alright. One or two more mod experiments before we move on. Oh, Dandelion's here. Hi, Dandy. It was a nice Dandelion. Can you guys see Dandelion? Dandelion. He looks so golden. He's technically a black cat, but he is outside so much his skin gets kind of bleached golden. Dandelion. Okay, so these are some fun graphs. We'll try one last mod, which will be putting it on this part. This makes it have to pick a side, and it gets pretty weirdly detailed on. Oh, whoa, that's cool. That's whoa. Look at all these weird things. All right, what if we said less than or equal? Let's try the other way. Greater than or equal. Well, that's pretty cool. All right. So we'll leave those there for a moment. Oh, squirrel. There's, it went the other way. We're getting a lot of wildlife this last week. A lot of squirrels, a lot of cats, a lot of birds. There's a bird nest up there too that I tried to show a few times. I guess I'll try and give one more view of the bird nest. It looks kind of cool. Bird nest up there. And also just a lot of other types of birds. Sometimes crows visit as well, but I can see some smaller ones up there that chirp. All right. So, someone's wondering if I know a certain exam, and I don't. And someone's asking a few more graph stuff, but I'm pausing on the graph for a moment. And we're not going to do the stream for extremely longer. We'll connect a few more bits of this Lego, but I don't think I'm going to be able to build the entire thing in today's stream for Lego Appreciation Day. Might have to build it just while I'm chilling and working on some editing or something later. But it's a fun activity to have been doing a little bit for the beginning portion of us hanging out. So feel free to leave any remaining thoughts or questions. Dandelion. Oh yeah, that's a dandelion. He is the nicest, softest boy. And recently he got ferminated with his comb called the Ferminator. And that made him really extra silky. He is the silkiest on the block. Well, more like the fluffiest. But he feels like silky cotton fluff. All right. So, I do think I'm going to wrap up the stream pretty quick. I will go through the rest of these instructions when I can to try and build a fun little car, and then we'll try and use it on a ramp or something.
As usual, I'll also probably find some more graphs for our next stream. Make sure to check out the bonus video that I put in the description here. And like I mentioned earlier, if there's any fans who want to help me out, I want to have some help putting timestamps in this stream and the last few streams that don't have it of when particular topics or activities happened, and then people can jump to them like chapters if you start the first one with 000 and do like a dash like times. And I will pin a comment or like the comments or stuff if people post any timestamps of when topics were covered. I sometimes have time to do that myself, but I might not have time to do it on this one. I need to work on editing some crazy Pandigital stuff and working on some other personal writing and stuff and hanging out with my friends later. But thank you all so much for joining me here. Make sure to see like the bonus video and the Discord and Patreon and links like that in the description here. The stream will post as a video as soon as it's done, although as usual the chat takes a little while to process. And someone said try one last one, and okay, we can try one last one. They said it's y equals tan 17x plus I think you probably mean that in parentheses plus cotangent 17x. Well, that's just like a brick wall. Whoa. Yeah. So yeah, this one has all these really thick spikes. All right. Well, thank you all for joining me here so much. I love you all, and I'll be back for a lot more content soon. There'll be a bunch of bonus channel stuff while I'm working on getting those main channel ones extra perfect, like that one about all those crazy numbers behind me, which will come in a few days. So, make sure you're tuned into the channels and the links. Have an awesome day, and I will see you next time.